In this video, we'll talk about matrix-matrix multiplication, or how to multiply two matrices together. When we talk about the method in linear regression for how to solve for the parameters theta 0 and theta 1 all in one shot, so that without needing an iterative algorithm like gradient descent. When we talk about that algorithm, it turns out that matrix-matrix multiplication is one of the key steps that you need to know. So let's, as usual, start with an example. Let's say I have two matrices and I want to multiply them together. Let me again just work through this example and then I'll tell you a little bit what happened. So the first thing I'm going to do is I'm going to pull out the first column of this matrix on the right. And I'm going to take this matrix on the left and multiply it by, a vector that's just this first column. Okay? And it turns out if I do that, I'm going to get the vector 11, 9. So this is the same matrix vector multiplication as you saw in the last video. I worked this out in advance, so I know it's 11, 9. And then the second thing I'm going to do is I'm going to pull out the second column of this matrix on the right, and I'm then going to take this matrix on the left, right? So take that matrix and multiply it by that second column on the right. So again, this is a matrix vector multiplication step, which you saw from the previous video, and it turns out that if you multiply this matrix and this vector, you get 10, 14. And by the way, if you want to practice your matrix vector multiplication, feel free to pause the video and check this product yourself. Then I'm just going to take these two results and put them together, and that'll be my answer. So it turns out the outcome of this product is going to be a 2 by 2 matrix, and the way I'm going to fill in this matrix is just by taking my elements 11, 9 and plugging them here, and taking 10, 14 and plugging them into the second column. Okay, so that was the mechanics of how to multiply a matrix by another matrix. You basically look at the second matrix one column at a time, and then you assemble the answers. And again, we'll step through this much more carefully in a second, but just want to point out also, this first example is a 2 by 3 matrix. I'm multiplying that by a 3 by 2 matrix, and the outcome of this product, it turns out to be a 2 by 2 matrix. And again, we'll see in a second why this was the case. All right, that was the mechanics of the calculation. Let's actually look at the details and look at what exactly happened. Here are the details. I have a matrix A, and I want to multiply that with a matrix B, and the result will be some new matrix C. And it turns out you can only multiply together matrices whose dimensions match. So A is an m by n matrix, so m rows, n columns. And I'm going to multiply that with an n by o matrix. And it turns out this n here must match this n here. So the number of columns in the first matrix must equal to the number of rows in the second matrix. And the result of this product will be a m by o matrix, like the matrix C here. And in the previous video, everything we did corresponded to the special case of O being equal to 1. Okay, that was to the case of B being a vector. But now we're going to deal with the case of values of O larger than 1. So here's how you multiply together the two matrices. In order to get, what I'm going to do is I'm going to take the first column of B and treat that as a vector, and multiply the matrix A with the first column of B. And the result of that will be a m by 1 vector, and I'm going to put that over here. Then I'm going to take the second column of B, right? So this is another n by 1 vector. So this column here, this is n by 1. It was an n-dimensional vector. Going to multiply this matrix with this n by 1 vector. The result will be a m-dimensional vector, which I'm going to put there, and so on. Okay, and so and then I'm going to take the third column, multiply it by this matrix. I get a m-dimensional vector, and so on until you get to the last column times the matrix times the last column gives you the last column of C. Just to say that again, the ith column of the matrix C is obtained by taking the matrix A and multiplying the matrix A with the ith column of the matrix B for the values of I equals 1 to up through O. Okay, so this is just a summary of what we did up there in order to compute the matrix C. Let's look at just one more example. Let's say I want to multiply together these two matrices. So what I'm going to do is first pull out the first column of my second matrix. That was my matrix B on the previous slide, and I therefore have this matrix times that vector. And so let's do this calculation quickly. This is going to be equal to, right, 1 3 times 0 3, so that gives 1 times 0 plus 3 times 3, and the second element is going to be 2 5 times 0 3, so that's going to be 2 times 0 plus 5 times 3, and that is 9 15. Okay. Oh, actually, let me write that in green. So this is 9 15. And then next, I'm going to pull out the second column of this and do the corresponding calculation. So that's this matrix times this vector 1 2. Let's also do this quickly. So that's 1 times 1 plus 3 times 2. So just that was that row. And let's do the other one. So let's see. That gives me what? 2 times 1 plus times 2. And so that is going to be equal to, let's see, 1 times 1 plus 3 times 1 is 4. And 2 times 1 plus 5 times 2 is 12. So now I have these two, and so my outcome, so the product of these two matrices is going to be, this goes here, and this goes here. So I get 9, 15, and 4, 12. And you may notice also that the result of multiplying a 2 by 2 matrix with another 2 by 2 matrix, the resulting dimension is going to be that first 2 times that second 2. So the result is itself also a 2 by 2 matrix. Finally, let me show you one more neat trick that you can do with matrix-matrix multiplication. Let's say as before that we have 4 houses whose prices we want to predict. Only now we have 3 competing hypotheses shown here on the right. So if you want to apply all 3 competing hypotheses to all 4 of your houses, it turns out you can do that very efficiently using a matrix-matrix multiplication. So here on the left is my usual matrix, same as from the last video, where these values are my housing prices, and I've put ones here on the left as well. And what I'm going to do is construct another matrix where here the first column is this minus 40 and 0.25, and the second column is this 200, 0.1, and so on. Okay? And it turns out that if you multiply these two matrices, what you find is that this first column, let me draw that in blue. Well, how do you get this first column, right? Our procedure for matrix-matrix multiplication is, the way you get this first column is you take this matrix and you multiply it by this first column. And we saw in the previous video that this is exactly the predicted housing prices of the first hypothesis, right, of this first hypothesis here. And how about the second column? Well, how do you get the second column? The way you get the second column is, well, you take this matrix and you multiply it by this second column. And so the second column turns out to be the predictions of the second hypothesis up there. And similarly for the third column. And so I didn't step through all the details, but hopefully you feel free to pause the video and check the math yourself and check that what I just claimed really is true. But it turns out that by constructing these two matrices, what you can therefore do is very quickly apply all 3 hypotheses to all 4 house sizes to get, all 12 predicted prices output by your 3 hypotheses on your 4 houses. So with just one matrix multiplication step, you manage to make 12 predictions. And even better, it turns out that in order to do that matrix multiplication, there are lots of good linear algebra libraries in order to do this multiplication step for you. And no matter pretty much any reasonable programming language that you might be using, certainly all the top 10 most popular programming languages will have great linear algebra libraries. And there'll be good linear algebra libraries that are highly optimized in order to do that matrix-matrix multiplication very efficiently, including taking advantage of any sort of parallel computation that your computer may be capable of, whether your computer has, multiple cores or multiple processors, or within a processor, sometimes there's parallelism as well, called SIMD parallelism, that your computer can take care of. And you should be able to, and there are very good free libraries that you can use to do this matrix-matrix multiplication very efficiently, so that you can very efficiently make lots of predictions of lots of hypotheses.